Hello, everybody. Hope you're all doing well. It's currently Wednesday, April 30th, 10:55 a.m. And I can't tell you how many times I've recorded this video. But let's get started. So, here's my program. Um, just a simple welcome message with some formatting. We got a do while, which prompts the user with with a menu, and then some error handling, and then we get into main choice 1. Which we'll see in a little bit with some more error handling, and then once again down here some more error handling, and then main choice 2, which we will see in just a second, and then main choice 3 obviously ends the program. So yeah, here's the FindMax algorithm. Check the base case. The size of the array, is 1, we return that value. If not, recursively iterate through the array, storing each value into max, and then we unwind that, comparing that value with its successor value until we get to the end. We check if the max value, or if the value currently stored in max is greater than the final index's value. We return max, and if not, we return the final index value. So yeah, go ahead and run this executable. Hello and welcome, recursion FindMax algorithm menu. As we can see, option 1 is to view output with user-provided elements. Option 2 is a step-by-step walkthrough of recursion with the decrease by 1 and conquer method. And then option 3 is to quit the application. Let's go ahead and do a little error handling here. Try to select an option. Select the hyphen option. That's not going to work. 0, P, none of that stuff is going to work. So we'll start with 1. Glad you can make it. The program is going to prompt the user to get the size of the array. So once again, hyphen, it's not going to work. Can't have an array with the size of hyphen, nor can you have an array with the size of P or 0 or -1. Let's go ahead and give it a size of 5. Now we need to provide the desired elements. So let's say index 1 would be equal to hyphen, not going to work. What about P? Not going to work. So yeah, we'll go ahead and do index 0, -1, 12, 23, 34, and 11. So here, with input size of 5, index 4 is equal to 11. This is the decrease by 1, this is the decrease by 1 and the recursion, to where we are cutting the input size of 1 and storing that current value in max, all the way until the base case. And as you can see, our max value is currently equal to -1 or index 0. And then we unravel this, and the algorithm starts by comparing index 1 with the max value, and not index 0 with index 1, because there's no need, as our max value is currently equal to the value stored in index 0. And then here we are comparing each value with its successor, we are comparing each value with the max value. So as you can see, index 1 equal to 12 with the max value of -1, 12 is greater. Index 2, which is equal to 23 with a max value of 12, 23 is obviously greater. Index 3, which is equal to 34 with a max value of 23, 34 is obviously greater. And then index 4, which is equal to 11 with a max value of 34. And as you can see, the max value of the given elements is 34. So that's a success. We'll go ahead and try the step-by-step walkthrough of recursion, decrease by 1 and conquer method. Here the goal is to help the user obtain a better understanding of how recursion and the decrease by 1 and conquer method go hand in hand in the FindMax algorithm. First, the algorithm checks the base case, ensuring that if the size of the array is 1, that number is returned. And as we can see here, this is the code which does that. Next, if the array size does not equal 1, the algorithm places the current index value into max, and then makes a recursive call back to itself, decreasing the array size by 1 until the base case is reached. This is the decrease by 1 and conquer method live in action. So here, this is the line of code in the array in the algorithm, which does that. And as we can see up here, that's what it is doing. Right here, it iterates through each index, storing that value into max until it reaches the base case, and that is the final value to be stored in max. After each index in the array has been iterated through, our recursion unravels the max value, which currently equals index 0 as compared to index 1. This process repeats itself until the final index has been reached. Finally, the algorithm determines if the last element in the array is greater than the value currently stored in max. And so once again, we can see that up here, we start with index 1, and we compare that value to max, and we go all the way up until the final index. And obviously, here, the final index is not greater than the value currently stored in max, so we're going to return that max value. And here's that code. As you can see, if max is greater than the final index, return max. If not, return the final index. And then once again, here's another example, this time using the array provided from our quiz. So as you can see, with an input size of 8, index 7 is equal to 2, input size of 7, index 6 is equal to 0, input size of 6, index 5 is equal to 8, so on and so forth until we reach the base case with input size of 1, index 0 is equal to 3. So the max value is currently equal to 3. And then we unravel, starting at index 1, comparing that with 5. 5 is greater than 3. Moving on to index 2. 2 is less than 5, so our max value stays. Moving on, index 3, which is equal to 9 with the max value 5. 9 is greater, and then as we can see, for the rest of the values in the array, our max value is going to continue to be 9. And that is once again proved right there. And yeah, this was mine. Once again, a very simple program. Everything can be done through the terminal. No need for extra applications. But I hope everybody else's project went well. And yeah, have a great day.